Disclaimer.
I accept.
No liability for damages resulting from imitation. Yes, you heard that right, 25,000 euros. That is the exact amount a company in Krefeld, Germany, lost in January 2026 after just a few hours of production downtime. What happened? It was actually a routine task. A fault in the system. The diagnosis in the control cabinet showed a peripheral error. A technician at the company simply replaced a fail-safe digital input module and then, nothing worked at all. In the next 6 minutes,
I will show you exactly why this supposedly standard procedure cost the company so much money. In this case,
25,000 euros, and why knowing the hardware details of the Simatic ET200 SP makes the difference between profit and loss. To help you understand the situation better, I will simulate the process exactly as it happened back then in Krefeld, based on the information provided by the technician on site. Take a look at the faulty module. We have the fail-safe electronic module here. On this F module, we can see two LEDs glowing solid red and one at the top flashing red. This is the classic fault display for a fail-safe ET200 SP module. For this video, I ordered an original, brand new FD module. It just arrived in the mail. Let's unbox it together. You can see the module here. But the crucial part is often the one you don't even notice at first glance. Normally, the replacement of fail-safe ET200 SP modules is a brilliant solution. You pull the defective module out of the base unit. Snap the new fail-safe module on correctly. Press the fail-safe acknowledgement button once. And the system runs smoothly again, as if nothing happened. The system recognizes the module immediately, the F destination address is matched, and you're done. If you want to be on the safe side, replace the module while the power is off. Now, I'm switching the system off. I replace now the fail-safe module when the device is switched off safely and without any risk. The defective module is removed. And the new module is correctly plugged onto the base unit. It's important to insert it cleanly and ensure it snaps into place properly. There the module is seated. Now, I'm powering the system back up. And this is exactly where the magic happens. The F destination address is automatically transferred completely without TIA portal. If everything is installed correctly, the system automatically recognizes the newly inserted fail-safe module during the restart. And that's exactly what you see here. The system has booted up, and there are no more error messages. Sounds simple, right? But in Krefeld, the human factor came into play. And here we come to the core of the problem. Every fail-safe ET200 SP module that requires an F destination address has a so-called coding element. This small white plastic part here permanently stores the F destination address on the base unit. The coding element snaps into the base unit automatically the first time an F module is installed and remains there permanently. This is a safety feature from Siemens to ensure that during a module replacement, you don't accidentally plug in the wrong module or lose the F destination address. This makes replacing an F module child's play completely without TIA portal. I think Siemens solved this very well. If you have a different opinion, let me know in the comments. My colleague in Krefeld accidentally pulled out the coding element along with the defective module. This normally never happens. I am trying now to pull the element out intentionally here in my lab by hand and with light tools without success. It is stuck absolutely firmly in the base unit, as you can see for yourself. I have no idea how the colleague managed to do that in the heat of the moment. He either ripped it out, or likely disposed of it or damaged it. The result? The destination address of the module was gone. The new module didn't know who it was, and the safety controller denied access. The plant remained in emergency stop, which paused the entire production for about 6 hours and cost the company €25,000. Why did it take so long? Because nobody expected the coding element to be missing. They replaced the module, the error remained. They installed a second module, the error remained. It wasn't until a specialist, me, arrived on site and inspected the base unit that it became immediately obvious. The coding element was missing. In the meantime, the assembly line stood still. Specialists had to travel, and spare parts were fetched by courier. In the industry, the clock ticks relentlessly. And that is how downtime costs, labor costs, and express logistics add up to this insane sum of €25,000. What do we learn from this? 1. Stay calm. Even under pressure, look closely when replacing modules. 2. Know your hardware. If you know how the ET200SP is mechanically coded, for example, you find the error in 5 minutes instead of 5 hours. If you want to avoid such expensive mistakes in your production or need support with your TIA portal programming, get in touch with me. And if you want to test your knowledge on real hardware, visit my website, www.sps-freelancer.eu. My remote rack is available to you there. Stay safe, stay error-free. Until next time. God bless us.